or in a different condition or in a different compounds. Okay, today we're gonna see the how can we balance the chemical reaction. Okay, this is session number 8. I welcome you all. Good afternoon, everyone. So about practically. Practically is the only hands-on learning app for 6 to 12 grade student, okay, where you can learn math, science concepts visually with 3D models. We also have a courses like a Vedic maths. We can learn robotics here. Okay, we have different types of courses. For that, you can log into our app, or you can also subscribe and like to Practically Live. That's on YouTube, where I'm conducting this session. Okay, let's start. So types of redox reaction. Now, redox reaction, there are different types of redox reaction. You might have seen those kind of reactions in an 8 or 9 standard, where you had seen, yes, Bhuvan Vardhan, it is not late, it's on time. Satti Babu, hi, very good afternoon. So there are different types of redox reaction, where you have combination reaction, decomposition reaction, disproportionation reaction, conproportionation reaction. But those combination, decomposition reactions you had seen already. You had seen those reactions in a earlier standard also. Okay. So in this section, we're gonna cover disproportionation and conproportionation only. Okay. So what is disproportionation reaction? See, disproportionation reaction is a reaction where same element, gets oxidized as well as reduced simultaneously. You can write, you can read the reaction here. It is a redox reaction in which same element present in a particular compound. Now that compound, it could be anything. It could be anything present in a definite oxidation state. It gets oxidized as well as reduced simultaneously. That kind of reaction is called as disproportionation. For example, suppose if you have a element called E, if this element is in oxidation state +2, for example, so from +2, if it gets reduced to +1, and it also gets oxidized to A3 plus. So on this side, it has got what? It has got reduced. On this side, it has got what? Oxidized. So same element has got oxidized as well as reduced. Now, obviously, for that you need to take 2 atoms of this, right? One atom of A2 plus has gone to A plus 1. Another atom of A plus 2 has gone to A3 plus. So this kind of a reaction, whenever it happens with a given element, it is called as a disproportionation reaction. Okay. So moving ahead, one of the reactant in a disproportionation reaction always contains element that can exist in at least 3 oxidation states. That is the prime condition. You can see here your A is existing in 3 conditions: +2, +1, +3. Your A is showing 3 oxidation state here: +1, +2, and +3. So there are 3 oxidation states, right? So each element should show at least 3 oxidation states. That's the condition. Next, the element in the form of reacting substance is in the intermediate oxidation state. Now, as far as your A is concerned, you can see here, there are 2 oxidation states of A here. One is A +1, another is A +3. And your A was actually in the +2. So +2 is the intermediate oxidation state, right? It is in between +1 and +3. That is why the main 2 conditions are: the element should be able to exist in 3 oxidation states. Secondly, the element which is undergoing disproportionation should be present in an intermediate oxidation state whenever it's happening. These are the 2 conditions for a disproportionation reaction to happen. Okay, I hope you must have understood it. If you have any doubt, you can ask me in the comment section. Yeah, yes, Satyababu, Bhuvan, if you have any doubt, you can ask me. Okay, chalo, moving ahead. Now, let's see some of the examples of a disproportionation reaction. In the last lecture, we had seen how can we find out the oxidation number of a given atom. Let's see here. In H2O2, the oxidation state of oxygen is how much? H2O2. Hydrogen is in a +1. So 2 hydrogen are in a +2. 2 oxygen are in a -2. There are 2 oxygen atoms. So -2 divided by 2, it has to be -1. So your oxygen here is in a -1. From there, it went to -2. That means it has got reduced. And from -1, it also went to 0. So oxygen has gone from -2 to 0, where it has got oxidized. And it also went from -1 to -2, where it has got reduced. That means your oxygen has undergone a disproportionation reaction here. Okay? Now, let's look at it for the sulfur here. Sulfur is in the S8, right? S8, that means it's an allotrophic form. And we had seen earlier that whenever any element, if it is present in an allotrophic form, that means its oxidation number has to be 0. Right? Its oxidation number has to be 0. Now, you have a 4s2 minus here. Now, sulfur is in a -2 oxidation number. Here, what is the oxidation state of sulfur here? Let's find out. S2O3 2 minus. Now, your sulfur oxygen is a 3 into 2, 6. 6 minus 2, 4. That means sulfur is present in a +4. But there are 2 sulfur, right? So, +4 divided by 2 is equal to +2. So, your sulfur is in a +2 oxidation state here. So, your sulfur went from 0 to -2. So, when it went from 0 to -2, it has got reduced. And whenever it went from 0 to +2, it has got oxidized. Okay. So, out of 8 sulfur atoms, 4 sulfur atoms has got reduced to -2 and other 4 sulfur atoms has got oxidized to +2. That is how your sulfur has undergone a disproportionation reaction here. Okay. Next, Cl2. Your oxidation state of Cl2 here is how much? It's 0, right? It is 0. Now, from there, it went to Cl minus and ClO minus. Now, in Cl minus, what is the oxidation state of chlorine? It's -1. And in ClO minus, it's +1. So, your chlorine has gone from 0 to -1, where it has got reduced. Then your chlorine has gone from 0 to +1, where it has got oxidized. So that is how your chlorine has gone from 0 to -1, which is reduction, and 0 to +1, that is oxidation. That is how your chlorine has undergone a disproportionation reaction. So these are some of the examples of a disproportionation reaction. Okay, moving ahead. Yeah, 2 KClO3 gives you 2 KCl plus 3O2. Now here, if you look at this reaction, the oxidation state of chlorine. What is the oxidation state of chlorine in KClO3? Let's find it out. KClO3. Potassium is +1, right? Each oxygen is in a -2. So 3 oxygens are in a -6. So +1 minus 6 is equal to -5. So potassium and oxygen together have a -5. That means chlorine must be having a +5 oxidation state. Okay. So oxidation state of chlorine here is +5. From there it went to -1. So basically your chlorine has undergone a reduction. Chlorine has undergone reduction and oxygen. What is the oxidation state of oxygen in KClO3? It's -2. From -2, it has come to 0. That means your oxygen has got oxidized. So in this particular reaction, chlorine has got reduced and oxygen has got oxidized. So these two elements are different, right? That is why we can't classify this reaction as a disproportionation reaction. Why? Because what is the condition of a disproportionation reaction? The condition is that the element which is getting oxidized as well as reduced at the same time should be same. Here the elements are different, right? Chlorine is getting reduced and oxygen is getting oxidized, and that is why this reaction, though it seems like a disproportionation reaction, but it is not. Okay, so moving ahead, I hope you must have understood this very well. If you have any doubt, you can ask me in the comment section. Yes, anyone? Okay, chalo, let's move ahead. Now, another type of disproportionation reaction, KClO3. Again, we had seen in the last example, the oxidation state of chlorine in KClO3 is plus 5, and in KClO4, you can find it out. Potassium again in plus 1. 4 oxygen, each oxygen is in a minus 2. 4 oxygens are minus 8. Plus 1 minus 8 is minus 7. That means your chlorine has to be in a plus 7. Right? So chlorine has gone from plus 5 to plus 7 and plus 5 to minus 1. Right? So that means your chlorine has got oxidized as well as reduced. When it went from plus 5 to plus 7, it has got oxidized, right? And when it went from plus 5 to minus 1, it has got reduced. So in both these cases, chlorine has undergone disproportionation reaction. Okay, now let's see the general reaction here. See, if you take X2, now this X2 means here, it could be chlorine, Cl2, it could be Br2, it could be I2. It cannot be fluorine. Why? Because look at here, when you are taking Cl2, Br2 or I2 here, which is X2 here, and OH minus, that means what? Basic medium. OH minus means basic medium, but a dilute basic medium. Okay, the oxidation state of your X here is 0. From there it went to minus 1 and to plus 1. So out of these two X atoms, one has got from 0 to minus 1, other has got from 0 to plus 1. Okay, that is how it undergoes disproportionation reaction. Now suppose if I take another X2 molecule, but this time again in a basic medium, no doubt about that. Here also it is a basic medium, but in the previous case it was a dilute base. This time it's what? It's a concentrated base. So when you have a concentrated base, what does it do? It brings your X2, which is your chlorine, bromine and iodine, from 0 to minus 1. That is constant here also, but apart from that, it takes this X2 from 0 to plus 5. So that means whenever you have a strong base or a concentrated base, it oxidizes your halogen atom to more extent. If you have a dilute, you will get 0 to minus 1 and 0 to plus 1. But if you have a concentrated medium, it converts 0 to plus 1 and 0 to minus 1 and 0 to plus 5. Okay, that is how this disproportionation reaction happens with the every halogen. For example, let me give you an example. Suppose if you have a Br2 here, Br2, and you got the NaOH. Let's take dilute. And then what do you get? You get NaBr, where your bromine is in a minus 1, plus you get what? You get HOBr, or I would rather write BROH. You can write BROH also, no problem with that. Sodium goes with this and you got OH, because sodium can be dissociated as NaOH can be dissociated as Na plus and OH minus. So with Na plus, Br minus has gone, and with OH minus, Br plus has gone. That means bromine here is in a plus. That is how your bromine can disproportionate from 0 to -1 and 0 to +1. Next, F2. Your fluorine does not or can't undergo disproportionation reaction as it is the most electronegative element. Because what is happening in disproportionation? In disproportionation, one of the element is getting reduced. That is possible with fluorine, obviously. Fluorine can get reduced, but fluorine cannot get oxidized. This is not possible. Why? Because fluorine is the most electronegative element. We have discussed about it earlier also, that fluorine being the most electronegative element, or what shall I call it, as a king of electronegativity, no species in the periodic table or in the chemistry can oxidize fluorine. And that is why fluorine, since it cannot get oxidized, that means it cannot undergo disproportionation reaction. Why? Because for disproportionation reaction to happen, the species should get oxidized as well as reduced. Okay. So then what will happen with fluorine? Suppose if you put NaOH into fluorine, dilute medium, fluorine is going from 0 to -1 and 0 to -1 only. That means your fluorine will only get reduced. Here also it will go from 0 to -1. It cannot get oxidized. The bottom line is that your fluorine cannot undergo disproportionation reaction, and it is the only element. It is the only element in the whole periodic table which cannot undergo disproportionation reaction. Okay. I hope you must have enjoyed it. If you have any doubt with this, you can ask me in the comment section. Yeah, everyone. Come on, you can ask me the question. Let's make it more interesting, more conversation. You can have more conversation here. Okay, chalo, moving ahead. Now, next reaction is con-proportionation reaction. Now, what is mean by con-proportionation reaction? See, con-proportionation reaction is something which is the reverse of disproportionation. That means what was happening in a disproportionation? One element was, for example, again, let's take example of A only. A is going from +2 to +1 and from +2 to +3. So in this case, both A +3 and A +1, both of them going towards A +2. So it is, so here A3 plus is getting reduced, A +1 is getting oxidized. So con-proportionation reaction basically is something which is exactly reverse of disproportionation reaction. That's why I have directly wrote here, reverse of disproportionation reaction is called as con-proportionation reaction. Okay. Next, in some of the disproportionation reactions, by changing the medium from acidic to basic or from basic to acidic, reaction goes in backward direction. For example, look at this reaction. See, this I2 plus H2O. Suppose if I take I2 plus H2O and if I keep this medium from acidic to basic, then you know what will happen. I2 will go from I2 to I minus plus IO3 1 minus. So if you keep the medium, basic, this reaction will go in reverse direction. But if you keep the medium acidic, then I minus plus IO3 1 minus, H plus is what? H plus indicates acidic medium, right? So I minus plus IO3 1 minus, if you keep acidic medium there, it will give you I2 plus H2. But if you keep the basic medium in the same reaction, this I2 plus H2 will try to go in a reverse direction when you have a basic condition. Same thing happens here also and here also. Here Ag plus 2 is going from Ag plus 2 to Ag, that means it is getting reduced, and Ag is going from 0 to plus 1, that means Ag is getting oxidized. Okay, so these are some of the types of a con-proportionation reaction. Okay, what is con-proportionation reaction? It is something which is exactly opposite to disproportionation reaction. Okay, chalo, moving ahead. Now, main part, balancing of redox reaction. Balancing of redox reaction. See, all balance equations, if you look at the all balance equation, they should satisfy two criteria. The very first criteria is atom balance. They should show the atom should be balanced. What is the meaning of that? That means, suppose if you have 5 oxygen on the left hand side, you should have 5 oxygen on the right hand side. If you have a 6 carbon atom on the left hand side, you should have a 6 carbon atom on the right hand side. That is how they can only be balanced. So the very first criteria for any reaction, be it a redox or any other reaction, to get balance is the atom should be balanced. The mass should be balanced. There should be same number of atoms of each kind in reactant and product side, obviously. Next is charge balance. The charge balance is really important for redox reactions. For redox reactions, it is important to balance the charge. That is obviously, see, the sum of actual charges on both sides of the equation must be equal. That means, suppose if you have a plus 11 charges on the left hand side, then you should have a minus 11 charges on the right hand side. Then and then only this can be called as balanced reaction. If suppose if you have a plus 11 on the left hand side and minus 9 on the right hand side, then this reaction is not a balanced reaction. Okay, so there are two main criteria for a reaction to be called as balanced. One is a atom balance and another is a charge balance. Okay, sure. So there are two methods of balancing the redox reaction. Let's see the two ways. The one is oxidation number method, another is ion electron method. Now we're gonna see both the methods here, oxidation number method as well as ion electron method. Okay, so let's see. Balancing redox reaction, the very first method is oxidation number change method. Oxidation number change method. Now, how can we use this method? See, remember, in a balanced redox reaction, the total increase in oxidation number must be equal to total decrease in oxidation number. That means, suppose if you have increase in oxidation number 5 on the left hand side, then you should have a decrease in oxidation number also 5 on the right hand side. Then and then only that reaction, that redox reaction can be called as a balanced redox reaction. Okay, so this is a kind of a equivalence. This is the equivalence which provides the basic. So basis of oxidation number method is total increase in OS. OS means oxidation state, or see, oxidation number is also called as oxidation state. These terms can be used interchangeably. Okay, so basically total increase in OS should be equal to total decrease in OS. Then only we can call that reaction as a balanced redox reaction. Okay, sure. So what are the procedures for it? First, select the atom in oxidizing agent whose oxidation number decreases. Now we know that oxidizing agent is a compound which oxidizes another compound, itself getting reduced. Now that means oxidizing agent is a compound which oxidizes another compound while itself getting reduced. Now that means your oxidizing agent is gaining electron. If it is gaining electron, its oxidation number is reducing, because it is reduction. But not the whole compound is undergoing a reduction. only one of the atom, selective atom, is undergoing change in the oxidation number. So what they're saying, select the atom from that oxidizing agent whose oxidation number is decreasing and indicate the gain of electron. That means how many electrons it has gained. 1 electron, 2 electron, 3 electron, just like that. Okay, next. Similarly, apply the same procedure for a reducing agent. What is reducing agent? We know that reducing agent is a compound which reduces another compound itself getting oxidized. Now, not the whole species of reducing agent is getting oxidized. Only one of the element from that must be getting oxidized. So that means one of the element is showing increase in oxidation number, right? So therefore, they are saying select the atom in a reducing agent whose oxidation number is increasing. Select the atom whose oxidation number is increasing and write the loss of electron. Now that loss of electron again could be 1, 2, 3, anything. Now what is the next step? Whatever electron you have lost and whatever electron you have gained, this should be made equal by doing a mathematical procedures. What are those mathematical procedures? Let's see. Cross multiply. That means suppose if decrease in OS, if decrease in OS is -2 and if increase in OS is +3, then to make this equal, what you need to do? You need to multiply decrease in OS by 3 and you need to multiply increase in OS by 2, which is nothing but means what? Cross multiply, right? That is why they are saying now cross multiply, that is multiply oxidizing agent by number of electron lost and multiply reducing agent by number of electrons gained. Okay, this equations and all these words which I have put here, it might seem a bit complicated, but you will understand in a better way once I start the question based on it. Okay, next step is also important. Balance the number of atoms on both the sides whose oxidation number changes in the reaction. Okay, then you need to balance the number of atoms on both the side whose oxidation number is changing. And lastly, in order to balance oxygen atoms, you need to add H2O molecules to the side which is deficient in oxygen. That means suppose on the LHS you have overall 11 oxygen and on the RHS overall you have a 9 oxygen. That means RHS is deficient in a 2 number of oxygen atoms, right? That means you need to balance those 2 oxygen atoms by putting 2 H2O molecule there. Now it has got balance. It's 9 plus 2, 11. You got 11 here. Now the question might rise in your head, then sir, why we are adding 2 H2O? That means to balance the oxygen atom, we are adding H2O, fine. But why only H2O? Why not any other molecule? It's because you are performing a redox reaction. Redox reactions are what? They are ionic reactions. And generally, I would say more often than not, ionic reactions are happening only in a water medium. That means you can add whatever number of water molecules, you can subtract whatever number of water molecules. That is the thing. Since the reactions are ionic, they are happening in a water medium. That is why you can always add a water molecule. Okay, that is why the side which is deficient in oxygen number should be added a number of oxygen atom on that side. Then lastly, balance the number of hydrogen atom by adding H plus ions in the hydrogen. That means whatever side which is deficient in hydrogen, for example, let's take example again. Suppose on the LHS you have a 15 hydrogen in all compound, and on the RHS suppose you have a 17 hydrogen. That means on the LHS you are short of 2 hydrogen. Then you need to add a 2 H plus on the left hand side. If the reaction is happening in acidic medium, or then If the reaction is happening in basic medium, then till here you need to do the everything same. Then you need to put OH minus on both the sides, whose number is equal to number of H plus ions. Okay, we will see that as the numerical comes. Okay, but for the time being, let's see how can we solve the question based on this by using all these instructions. Okay, chalo, moving ahead now. Now balance the following reaction by oxidation number method. They are asked balance the following reaction by oxidation number method. Excuse me. So firstly we need to find out the oxidation number for every element. See, for the oxidation number of copper is 0 here. Oxidation number of copper is 0. Then what is the oxidation number of nitrogen? In HNO3 you got +1 and 3 oxygen. 3 oxygen will have what? -2 into 3, -6. So +1 -6, it's -5. So apart from nitrogen, you have hydrogen, oxygen in -5. That means nitrogen must be having a +5. Right? So you have a +5 here. Then you got a nitro group here. See, nitro group NO3 1 minus. The charge on NO3 1 minus is -1. Okay, NO3 1 minus. That means there are two NO3, right? That means 2 minus. If the 2 minus are there, that means copper must be having a +2. Then NO2. In NO2, your nitrogen is in a +4. Now this is quite evident. If the oxygen is in a -2, if oxygen is in a -2, there are two oxygen which are in -2, right? So two oxygen in -2, two oxygen in -2, that means nitrogen has to be in a +4. Okay, now let's see decrease or increase in OS. Okay, first increase in OS. OS means oxidation number. Okay, let's write ON only. Increase in OS. Increase in OS is happening for copper. Copper is going from 0 to CuNO3. So it's going from 0 to +2. So increase in OS is equal to how much? It's a +2. That is your equation number 1. 10. Then what do you have? Decrease in OS. Decrease in ON for the reaction HNO3. HNO3 is going from HNO3 to NO2. So nitrogen is going from +5 to +4. And decrease in OS is equal to how much? -1. So that is your equation number 2. So as I told you earlier, to make the reaction balanced, you need to make increase and decrease in OS same. So what do you need to do here? You need to multiply equation 2 by 2, equation 1 by 1. So then what do you have? Then you will have CuNO3 as it is. So multiplying this by 2, then you will have a -2 here, right? And you will have a 2HNO3 plus 2NO2. Then adding them together, what do you get? You get Cu plus 2HNO3. Then you have a CuNO3 plus 2NO2 plus H2. Okay, so now increase and decrease in OS have got balance, but some atoms are still need to balance. See, nitro group NO3, you can see there are 4 nitrogen here, the 2 NO3 group here and 2 NO2 group are here. So basic there are 4 nitrogen. Okay, that means you should have 4 nitrogen on the left hand side also. Out of those 4 nitrogen, only 2 nitrogen has got reduced from +5 to +4. Other 2 remains as it is. That is why you can always add it. No problem with that. So you will have Cu plus 4HNO3, CuNO3 to plus 2NO2. Okay. Now let's look at if everything is balanced or not. Let's look at for the oxygen now. You have a 12 oxygen on the right hand side, and you have a 3 into 2, 6, 6 plus 4, 10 oxygen on the right hand side. That means you will still need 2 oxygen there, out of which 1 oxygen is already there in the form of H2O. That means you need to add one more H2O. So if you add one more H2O, what do you have? You will have a 2 H2O there. And that is how, in terms of oxygen, reaction has got balance. Now let's look at for the hydrogen, if it is balanced or not. See, there are 4 hydrogen here on the left hand side. And how many hydrogens you have got here? 4 only on the right hand side. So hydrogen is also balanced, and that is how this reaction can be balanced. Now this is your balanced chemical equation. Okay, so I hope you must have enjoyed it. You can ask me if you have any doubt with this. Okay, so what is the basic thing? You should be balancing increase and decrease in OS first, and then you can go for the other atoms, and lastly you need to go for oxygen and the hydrogen. Hydrogen is the atom which should be getting balanced in the very last step. Okay, chalo, moving ahead. Next, SO4O6 2 minus plus aluminium gives you H2S plus Al3 plus. Now here this reaction is happening in acidic medium. Again, the oxidation number method. Okay, what is the first step? To write the oxidation states. Now S4O6 2 minus. Let's find this out. 6 into 2, 12. 12 minus 2, 10. 10 divided by 4, 2.5. So each sulfur is in a 2.5 oxidation state here. The sulfur's oxidation state is 2.5. Here your sulfur is in a -2, right? Because with the H2S, hydrogen is in a +1. So 2 hydrogen are in a +2. Then sulfur has to be in the -2. Sulfur is in a -2. Aluminium is in a 0. And here it's in a +3. Okay. So let's write the increase in OS first. Here I have kept this place this time. Increase in OS is equal to, it's happening for aluminium. Aluminium is going from 0 to +3. So increase in OS is equal to how much? 3. That is your equation number 1. Now second, decrease in OS. S4O6 2 minus. Now firstly you need to balance this. Why? Because you can see here in S4O6 you got 4 sulfur, but in H2S you got only 1 sulfur. That means you need to write 4 only here. S4O6 2 minus 4 H2S. Now you can write the sulfur. Sulfur is going from 2.5 to -2. So 2.5 to -2 is how much? It is equal to 4.5, right? But that is for each sulfur atom. That is why I should write decrease in OS. Decrease in OS per atom. Decrease in OS per atom is how much? -4.5. Because each sulfur is going from 2.5 to -2, no? So that means decrease in OS per atom has to be -4.5. But we got a 4 sulfur atom, right? And therefore, overall decrease in OS is equal to -4.5 into 4. That is equal to -18. That is your equation number 2. So you can see here, increase in OS is equal to 3. That is what is giving you equation number 1. And decrease in OS is minus 18. That is in equation number 2. Now you need to make increase and decrease in OS same. Remember, then what do? You need to multiply equation 1 by 6 and equation 2 by 1. And then obviously adding them together. Now I'm skipping that step. By multiplying 6 and adding, what do we get? Let's see. Then you get S4O6 2 minus plus 6 aluminium is giving you 4H2S plus 6Al plus 3. Right? This is what you got here. Now what you do? Sulfur is balanced, aluminum is balanced, everything is balanced. You need to balance the oxygen now. How many oxygen you have on the left hand side? You got the 6 oxygen. And on the right hand side, you got 0 oxygen, right? So how can you balance this? By adding 6H2 molecule on the right hand side. So you will have S4O6 minus plus 6Al plus 4H2S. Then you have a 6Al plus 3 plus 6H2O. So your oxygen is got balanced now, right? What you need to balance now? The hydrogen atom in the last step. Now you can see here, you got 0 hydrogen on the left hand side, but you got the 12 hydrogen on the right hand side. So what you do? How can you balance this? By adding the 12H plus ion on the left hand side. You add 12H plus S4O6 2 minus plus 6 aluminium gives us 4H2S plus 6Al plus 3 and plus 6H2. So now if you look at, you got 4 sulfur on the left, 4 sulfur on the right, 6 oxygen on the left, 6 oxygen on the right, 12 hydrogen on the left. Oh, I made a mistake. Sorry. I made a mistake here. We need to drop this down. You got more hydrogen here. You can see here you got 6 into 2, 12. 12 plus 8, you got 20 hydrogen on the right hand side. Sorry. That means we need to add a 20H plus. Sorry, my bad. 20H plus, not 12. Okay. So that is what, and that is how you can balance the particular reaction by using this method. Okay. This is the way by which you can balance this. Okay. So moving ahead with this now. Next, balance the following reaction by oxidation number method again. Okay. It is the same kind of reaction. S2O3. Again, this reaction happening in acidic medium. Okay. Let's find out change in oxidation number. So chromium oxidation number here is oxygen 7 into 2, 14. 14 minus 2, 12. That means chromium 2 must be having a plus 12. So each chromium must be having a plus 6. So from plus 6 is going to plus 3. So decrease in OS. If you write it for the chromium, it goes from Cr2O7 to minus to Cr3 plus. Now one more thing. You got a 2 Cr2. Okay. You got 2 chromium here. That means you need to balance this by writing 2 Cr plus 3 here. Okay. Now, what is the decrease in OS here? Chromium is going from plus 6 to plus 3. So if you write the decrease in OS, the decrease in OS is equal to 3. Decrease in OS is equal to 3 per atom. Right? But you got 2 chromium atoms here. And therefore, the overall decrease in oxidation state has to be 3 into 2, that is equal to 6. That is your equation number 1. Second, H2O3 H2O3 2 minus is forming H4O6 2 minus. Now you need to find out the oxidation state. First of all, you need to balance the atoms. How can we balance it? See, in H4O6 2 minus, you got how many sulfur atoms? You got the 4 sulfur atoms there, right? You got the 4 sulfur atoms there. And here you got how many? 2 sulfur atoms. That means you need to balance it by putting 2 here. Now you have 4 sulfur atoms on each side. Okay. Sulfur 3 into 2, 6. 6 minus 2, 4. 4 divided by 2 plus 2. That means sulfur's oxidation state is plus 2 here. Here 6 into 2, 12. 12 minus 2, 10. 10 divided by 4, 2.5. So sulfur is getting oxidized from plus 2 to plus 2.5. So if you write the increase in OS here, increase in OS is equal to 0.5 per atom, right? But how many sulfur atoms are there? 4 sulfur atoms are there, right? Therefore, overall increase in OS is equal to 0.5 into 4, that is equal to 2. That is your equation number. So here you got 2 increase in OS, 6 as decrease in OS. So again, how can we balance this? We need to multiply equation 2 by 3 and equation 1 by 1. And then you should add them, right? Then what do you have? Cr2O7 will remain as it is. Cr2O7 2 minus, right? And you are multiplying H2O3 by 3. That means you will have how much? 3 into 2, 6. 6 H2O3. 6 H2O3 2 minus is giving us 3 H4O6 minus plus 2 Cr plus 3. So that is why, that is how you can balance this now. Now oxygen atoms. How many oxygen atoms are there? On the left hand side, 6 into 3, 18 plus 7. You got 25 oxygen atom on the left hand side. On the right hand side, you got 6 into 3, 18 oxygen. So that means right hand side is short of 7 oxygen atoms, right? Then therefore you should add 7 H2O on the right hand side. Then what do you have? 6 H2O3 2 minus plus Cr2O7 2 minus, giving us 3S4O6 2 minus plus 2Cr plus 3 plus 7H2O plus 7H2. Now oxygen has got balance. Now what you need to balance? Hydrogen. How many hydrogens have you got on the left hand side? 0. How many hydrogens you have on the right hand side? 14, right? That means you should add 14 hydrogen on the left hand side. Then you have a reaction is balanced. 14H plus 6H2O3 2 minus plus Cr2O7 2 minus, giving us 3S4O6 2 minus plus 2Cr plus 3 and 7H2. So if you look at the reaction, 12 sulfur are there on the left, 12 sulfur on the right. 2 chromium on the left, 2 chromium on the right. 6 into 3, 18 plus 7, 25 oxygen on the left, 25 oxygen on the right. 14 hydrogen on each side. Now you can say your reaction is balanced. That is how you can balance the reaction by using oxidation number change method in a acidic medium. Okay, let's see how can we perform oxidation number change method in a basic medium. Okay, sure. Next, now this one is a basic medium. See, Cl2O7. Here oxygen is in a -2 into 7 -14. So chlorine must be having a +14. So each chlorine must be having in a +7 OS. So +7 to Cl2 1 minus. Here chlorine is in a +1 oxidation state. Oxygen here is in a -1 and here it's in a 0 oxidation state. We had seen all these things previously also, that how oxygen is undergoing disproportionation. Okay, and what is the oxidation state of oxygen in H2O2? Okay, so let's go for the decrease in OS first. Cl2O7 is giving me ClO2 1 minus. Now there are 2 chlorine on the left. That means you should add 2 here to make the chlorine balanced. So each chlorine is going from +7 to +1. So therefore, decrease in OS is equal to 6 per atom, right? But you got the 2 chlorine atom here, and therefore the overall decrease in OS is equal to 6 into 2 is equal to 12. That is your equation number 1. Then you have equation number H2O2. H2O2 is giving you O2. Now in H2O2, oxygen was in a -1 oxidation state. So from -1 is going to 0. Here the oxidation state of oxygen is 0, right? So if you write here, it's increase in OS. So increase in OS is equal to 1 per atom. But there are 2 oxygen atoms, no? Therefore, you have overall increase in OS is equal to 1 into 2, that is equal to 2. That is your equation number. So increase in OS is 2, decrease in OS is 12. Then what you need to do here? You need to multiply equation 2 by 6 so that this will become 12, and multiply equation number 1 by 1. And then you are adding them together. Then what do you have? Let's see in the next slide. 6H2O2 plus you have what? Cl2O7 giving us 2ClO minus ClO2 minus, ClO2 1 minus, plus lastly 6O2. So that is how you can balance this. Now this reaction is balanced in terms of increase and decrease in OS, but in other terms it is yet to be balanced. What are those other terms? Oxygen. Let's look at how many oxygen are there on the left hand side. On the left hand side you got 6 into 2, 12, 12 plus 7, 19 oxygen on the left hand side. How many oxygen on the right hand side? 2 into 2, 4, 4, 6 into 2, 12, 12 plus 4, 16. That means you are short of 3 oxygen on the right hand side. Therefore, you add 3H2O on the right hand side. 2ClO2 1 minus 6O2 plus 3H2. right? Now oxygen has got balance. What is yet to be balanced now? Hydrogen. How many hydrogen are there on the left hand side? 12 hydrogen here. How many hydrogen you have on the right hand side? 6 hydrogen. That means you need to add 6 H plus ion on the right hand side. And therefore now you will have 6H2O2 Cl2O7 giving me 2ClO2 1 minus 6O2 3H2O plus 6H plus. Now remember, this reaction is happening in what medium? Basic medium. So if the reaction is happening in basic medium, you need to add the equal number of OH minus as there are H plus ion on both the side. That is why now you need to add 6 OH minus on the both sides of the equation. So on the left hand side, you got 6 OH minus plus 6 H2O2 plus Cl2O7 plus 2 ClO2 1 minus 6 O2 plus 3 H2O 6 H plus and 6 OH minus. Now 6 H plus and 6 OH minus will together give me 6 H2O, and this 6 H2O plus 3 H2O will together give me 9 H2O. That is why the final balance equation should look like this: 6 OH minus 6 H2O2 Cl2O7 giving us 2 ClO2 1 minus 6 O2 plus 9 H2O, and that is your final balanced equation. Remember, whenever you are balancing reaction in acidic medium, there should be at least one H plus ion extra. Whenever you are balancing reaction in acidic medium, there should be at least one H plus ion extra, and whenever you are balancing reaction in basic medium, there should be at least one OH minus extra, because OH minus is the phase of basic medium and H plus ion is the phase of acidic medium. So this reaction was happening in basic medium and we have got OH minus extra here. Okay, remember always that. Okay, chalo. Now we will skip this question because this is again belonging to oxidation number method. Okay, let's move to the next method. If we get the time, we can solve this. Okay, see the next method. The next method is what? It's an ion electron or a half cell method. Now this method is not something different. This method is just like that. But what happens here? You consider you consider the reaction is into two halves: oxidation half, reduction half. Basically here also you assign the oxidation number to each element present in the reaction. Okay, then you convert the reaction in ionic form by eliminating the elements or species which are not going either oxidation or reduction. So you are taking only those species which are undergoing either oxidation or reduction. Okay, then you identify oxidation, reduction occurring into the reaction. Okay, then you split the ionic reaction. Then you split the ionic reaction in two halves, one for oxidation, other for reduction. Okay, you divide the reaction in two half: oxidation half, reduction half. Then you balance the atom other than oxygen and hydrogen atom in both the half reaction. Okay, you don't need to remember these steps. You will come to know as I start solving the question. Okay, then now balance the oxygen and hydrogen atom by adding H2O or H plus ion, as we had seen earlier also. It is exactly same. By the following way: one extra, same thing is there, nothing is changed. Okay, you need to multiply it by suitable factor. All of those remains, everything remains same. You only need to divide the reaction in two half: oxidation half, reduction half. Okay, let's see how we can do that. Say this reaction. Balance this reaction by ion electron method This reaction is happening in acidic medium. Now you can see here FeSO4 is in the +2 oxidation state here, and it's in a +3 oxidation state here. How? Fe2SO4 3. Charge on each sulfate is -2. There are 3 sulfate, right? So 3 sulfate will have a -6 charge. Therefore 2 ion will have a +6 charge, and each ion will have a +3 charge. That is why I'm saying it's in a +3 here, it's in a +2. So this is your oxidation half. Let's write it here. Oxidation half. How is the oxidation half? FeSO4 is giving me Fe2SO4. You can clearly see here there are 2 ion here, there's only 1 ion here. That means we need to take 2 Fe2SO4, right? 2 FeSO4. So each ion is going from +2 to +3, right? So each ion is showing increase in OS, or I would rather say, what are the term that we used here? Remember what is this term? Oxidation reduction. You can use the other term, the gain or loss of electron. Let's see if this is the gain, loss of electron, right? So loss of electron, I would rather write overall loss. Overall loss of electrons here is 2, right? Because each ion is going from +2 to +3. That means it is losing 1 electron. So if you have 2 ion, it will lose 2 electrons overall. So that is your equation number 1. Then write the reduction half. Reduction half. Now reduction half, you can see here KMnO4, your manganese is in a +7 there. In KMnO4, your manganese is in a +7, and in MnSO4, your manganese is in +2. +2 +7. Now these are the only species. That means FeSO4, KMnO4, Fe2SO43 and MnSO4. These are the only species which are showing change in oxidation number. If you look at here, H2SO4 and H2O, they are not showing any change in oxidation number, and that is why we have not taken them into consideration while writing this oxidation and reduction half. Okay, now reduction half. Now here you have a gain, overall gain. No need to write overall here because you got single atom. You got single atom here. So gain of electrons. How many? Going from 7 to +2. That means you got gain of electrons is equal to 5. And that is your equation number 2. So what do? We write gain and loss of electrons should be same. And that is why equation number 1 has to be multiplied by 5 and equation 2 has to be multiplied by 2. What would this give me? It will give me 5 into 2. It will give me 10 Fe. It will give me 10 FeSO4 plus 5 Fe2SO4 3. Loss of electron is equal to how much? 10. Equation number 3. And then you have what? KMnO4. That will stay. Sorry, you will become 2 KMnO4 now. 2 KMnO4 is giving me 2 MnSO4. And then you have a gain of electrons. Is how much? 10. 5 into 10. 10, 10 gets cancelled. Both the sides are getting added. Then what do we get? Let's write it here. 10 FeSO4 plus you get 2 KMnO4, 2 KMnO4, you got H2SO4, which gives you 5Fe2SO4 3, right, plus 2 MnSO4. And how many water molecules are there? Only single, right? Now everything has got balance as far as electrons gain and lost are concerned. Now we need to see whether we have balanced the oxygen atoms or not. Okay, let's count the oxygen atoms. So here 10 into 4, 40, 40 plus 8, 48, 48 plus 4, you got 52 oxygen atoms. One more thing before going for oxygen balancing, let's look at how many sulfate are there. If you look at on this side, you got SO4 3, 15 plus the 17 sulfate are there here. How many sulfate are there? Why I'm writing directly for sulfate? Because sulfate is not showing any change in oxidation state. So the species which is not showing any change in oxidation number, you can balance it directly. You can balance it directly. How many sulfate are there on the left hand side? 10 sulfate are already here. You got 1 sulfate. So 10 sulfate, you need to make it 17. That means you need to make 7 H2SO4 here already. So 10 FeSO4 gives you, sorry, plus 2 KMnO4 plus 7 H2SO4. Now sulfate are balanced. You have a 5 Fe2SO4 3 plus 2 MnSO4 plus H2. So sulfate are balanced. Let's see it for the oxygen. 10 into 4, 40, 40 plus 8, 48, and 7 into 4, 28, right? So 28, so this is 28 plus 8, 36, 36 plus 40, let me count it again. 10 into 4, 40, 40 plus 8, 48, 48 plus 28, it makes 76 oxygen atom on the left hand side. How many oxygen you have on the right hand side? 4 into 3, 12. 12 into 5, 60. 60 into 8, 68. Plus 1, 69. You have 69 oxygen. That means 7 oxygen are less on the right hand side. That means you need to add 7 H2O. Look at here, 76 H2O, 69 H2O. So you need to add a 7 H2O on the right hand side. So once you add a 7 H2O, 7 H2O plus this 1 H2O, it will become 8 H2O. Okay, that is why I will write it directly. 10 FeSO4 plus 2 KMnO4 plus 7 H2SO4. Then you have a 5 Fe2SO4 3 plus 2 MnSO4, and then you need to add how many? 7, 8 H2. Okay, now reaction was happening in acidic medium, so we need to see if the hydrogen are balanced or not. If you look at on the left hand side, you got 14 hydrogen. If you look at on the right hand side, you got 8 into 2, 16 hydrogen. That means left hand side is short of 2 hydrogen, which can be balanced by putting or adding 2H plus on the left hand side. 2H plus, 10 FeSO4, 2 KMnO4, 7 H2SO4, adding 5 Fe2SO4 3, 2 MnSO4 plus 8 H2. And that is how this reaction is now balanced. That is the way you can balance the ion electron method. Now, what kind of question generally being asked in the JEE exam? See, what do they do is that they will keep the same equation, but they will keep the place here as empty. 10, here also bracket empty, bracket empty, bracket empty, 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 and empty. And then they will ask you what are the numbers which are more suitable here. And then they will give you option. For example, the correct option would be 2, 10, 2, 7, 5, 2, 8, like that. Now they will shuffle these numbers. They will shuffle these numbers and they will give you different options for you to get confused. So if you know this basic very well, you should be able to balance it very well. Okay, so that's it for today. That is how we have covered both the methods of balancing. I have told you how can we balance this in both medium, acidic as well as basic. Okay, now the way we have solved it for the acidic medium, if the same question comes for the basic medium, you just need to add equal number of OH minus on both the side as there are H plus ions. Then those H plus ion and OH minus ions together will give you H2O molecule. And then you can cancel out some of the equal number of H2O molecule on either side, which ultimately will give you the final balanced chemical equation. Okay, I hope this must have been very helpful for you. Okay, that's it for the today. In the next lecture, we will cover the concept called equivalent concept from the same chapter. Now, to get more such lectures, to get more such sessions, you can subscribe to our channel on YouTube, the name Practically. Okay, you can log into our app where you can see the various interesting things, where you can learn the robotics, you can learn the biology, you can learn the physics, chemistry in an interesting way. We have a simulation model there where you can learn all of those in very interesting way. Okay, you can use your cell phone for understanding the different kind of concepts in a very innovative way. You will really enjoy it. For that, you need to log into our app, and to get more such content, please like, share and subscribe to our channel on YouTube. Its name is Practically. Okay, this is Mayur More signing off. Bye bye everyone. Let's see in the next lecture.